afternoon, everyone. My name is Thayvitak Laksachai.
My name is Oramato Taipo.
And my name is Yurkong Jasitel. We are from Sadringa School. Before we present our project, have you ever wondered that the sandglass takes only a fixed duration? If I want a longer duration, do you need to buy a new one? Oh, I think I don't want it. Okay, from this problem, today we are going to talk about the project, the relation of angle, quantity, the bead diameters, and the shifting time of the bead sandglass. First of all, we will talk about source and importance. The source of this project. A sandglass is timer. One sandglass that can count time in one value. But our team want to make a sandglass that can count time in many values by using the length of a sandglass as a variable and use bead instead of sand because it's easier to determine of the relations. Next, this is the purpose of this project. We want to study the bead sandglass that can count time in many values, and we want to study the factors that affect the shifting time, such as the flow of beads in different degrees, the number of beads, and the last one is the bead diameters. Letters. Let's look at the content that will be used in this project. The first, trigonometry. The second, function. And the last one is the exponential function. Next, this is the equipment that will be used in this project. This is two empty bottles. This is the beads. And the last one is the fan frame. Our project, a sandglass that must be rotated. So we test by tack a sandglass on the fan frame. And these are examples of sandglass in different degrees.
Next is an example of our invented seamless sandglass. Before each experiment, we will define a standard variable or the variable control is as follows. 1. Bottle with a volume of 360 ml. 2. Bottle cap hole side diameter 2.2 cm. And the last one, 250 bead with each bead diameter 0.85 mm. Next, the experimental result. Therefore, we divide the experiment into 3 teams, with each team conducting 3-time experiment, plotting in the program. The first experiment shows the relationship between degree and time variation. We will start timing after the bead reach the bottom of the bottle. Draw a chart by the x-axis represent the different degree and the y-axis represent the measurement time. Show as we can see. The second experiment is the relationship between the bead diameter size and time variation. By changing the size of the bead from a variable to the desired size, so we obtain the time average based on the size of the bead. Then, the x-axis represents the diameter in millimeter degrees and the y-axis represents the measurement time. And the last experiment is the relationship between the number of the beads and time variation. By changing the number of the beads, so we obtain the time average based on the number of the beads. Then the x-axis represents the number of the beads and the y-axis represents the measurement time. And the result shown as you can see.
Alright, first of all, let me talk about the calculating part. From the first experiment, it shows the relationship between the angle and the changing time. We use the exponential equations, namely 1 and 2, to create two functions of log A and log B equations, namely 3 and 4. To calculate the constants of A and B. And once you calculate the log B from the first experiment, look like this. When you get the log B from the first experiment, you can find the log A, and using the functional relation to calculate the resulting of log Y and total side as follows. And next, the second experiment shows the relationship between the diameter diagram of the beads and the changing time. To use the knowledge of exponential integral equation, and functions of log A and log B equations is introduced. Once you calculate the log B from the second experiment, look like this. When you get the log B from the second experiment, you can find a log A. And this is the finally resulting of log Y and tolerance are as follows, as you can see in the slide. And the last experiment shows the relationship between the number or the quantity of the bits and the changing time through the knowledge of functional relation in form of linear equations which were calculated by the formula. The value will obtained from the table 1. Equation 1 and 2 were as follows. And last, we use determinant to store two equations and showing the following formula as you can see in the slide. The x shows the amount of particles and y shows the time spent in seconds.
Later, let's look at the overall operation, which is static equation. X value is amount of beats, and y value is time spent in the seconds. The first formula is from relations between the degree and time variations. The second formula is from relations between the beat diameters and time variations. And the last formula is from relations between the number of beats and time variations. And the last slide is the suggestions. Making and turning a sandblast with little tolerances by using good quality materials and should be invented to increase efficiency. From we start the project, we know that we don't need to buy a new sandblast because we can apply new formulas for making a new sandblast that can cut time in many values. For today, thank you for your attention and we hope we again next chance. Before we part, I would like to say 3, 2, 1. Thank you very much. ขอบคุณครับ